These are your 10-3B notes, geometric series. So this is the sum of a geometric sequence, just like an arithmetic series is the sum of an arithmetic sequence. We denote the sum by S sub n. N implies how many terms we're going to be adding up in the series. Okay, and there's actually two formulas for this, because if you don't have two formulas, to find one of the missing values gets really tricky if you need to use the other formula. So we didn't do this with the arithmetic because it wasn't so difficult. So one of the formulas here is when you use the first term, you have the constant, the common ratio, you know the number of terms, but you don't have a sub n. So we don't have an a sub n value. And then the second one is using a sub n, but we just don't know what a sub n is. We don't know the number of terms in that sequence. So we know we have the first term, we have the last term, but we don't have the n value. Okay, and usually what happens if you're missing the a sub n or you're missing the n value, you could go back and use the formula from before, but it involves using logs and it gets really messy. So what they do is they actually give you two different formulas. Now the formulas are really similar. Okay, the only part that's different, if you notice, that second part that you're subtracting, they're basically saying that the first term times the common ratio times n is equivalent to a sub n, the last terms, times r. And so everything else stays the same. It's just that last part is different. So on the next slide, I'm going to show you how this second formula comes about. So if you look at this, I have a sub n is equal to a sub 1 times r to the n minus 1. So what I'm going to do is I'm going to show you how I can get a value. Oops, it just disappeared. I'm going to actually show you that a sub nr is equivalent to a sub 1 times r to the n. So I'm going to start off with a sub n, and I'm going to multiply both sides by r. You're allowed to do that. So if I multiply this side by r, and then I'm going to multiply this side by r as well. Whatever you do to one side, you can do to the other. So now what I have is that a sub n times r value that's in one of those sum formulas. On the right-hand side, though, what happens is I have an r times an r, and usually when you have common bases, you're allowed to clean them up. For instance, if I have x squared times x cubed, I could rewrite that as x to the fifth by adding their exponents. So when I want to clean this up right here, I actually want to say that that's r to the first, and so I'm going to add the exponents. And when I add those exponents, I would have r n minus 1 plus 1 just becomes n. The minus 1 and the plus 1 of the exponents cancel each other out. And so what this whole right-hand side cleans up to is a sub 1 times r to the nth. And so this statement right here allows us, if I have this, which is that portion of that formula, it is equivalent to, I can replace it, and I thought this was going to appear. And so what I can do, since a sub 1 r to the nth is equivalent to a sub n times r, I can replace that value in the formula. So remember, that's the only part that changes, is that second part. So before you choose what sum formula you're going to use, you kind of have to list all of the pieces that you have. And don't forget that you have that formula from before. But by having two summation formulas, it sort of eliminates having to use the old formula from the previous day. So let's go ahead and just kind of list what we have and kind of go from there. So the first example, I have a sub 1, I have the common ratio r, and I have the number of terms. So looking at this, I would actually want to use, I have a sub 1, I have n, and I have r. So I'm going to use this formula right here. That's the formula that I need to use because I don't have the last term. So I'm going to do the sum of the 7 terms is a sub 1 minus a sub 1 times r to the n all over 1 minus r. So I want to show you again, that's what we have as our formula, r sub n. So I'm going to plug in everything. We're going to find the sum of the first 7 terms starting at 16 minus 16 times a half to the 7th power all over 1 minus a half. Okay, this will work every single time. Now, order of operations, again, are key here. In order to do this, I can't do the 16 minus 16 because that's subtraction, and I can't subtract because that's really not a 16 there. That's really not 16 times a half. It's 16 times a half to the 7th power. So the very first thing that has to happen here is I have to raise a half to the 7th power. If you're going to use your calculator, put it in as a fraction, or raise the numerator as a power, which is 1 to the 7th is 1, and 2 to the 7th power, which is 128, I believe. Okay, do not use decimals here. You're going to want to use the fractions. And so this is what I'm left with. So before I can do the subtraction, and then 1 take away a half is just a half. So we got this crazy fraction here. Before I can subtract the 16s, that's really not a 16. That's 16 times 128, or 1 over 128. So I'm going to actually multiply that out. 16 times that fraction, 1 over 128, leaves me with a portion, a fraction. And actually 16 goes into 128, I believe, 8 times. So when you actually do that multiplication, you get 16 minus 8. Or I'm sorry, 16 minus 1/8, because 16 goes into it 8 times. That's 1/8 all over a half. Now, if you just think through fractions, when you take an 1/8 away from 16, that will leave you with 15 7/8 divided by a half. Okay, you got this crazy fraction. And then to clean that up, to take away the half, or to clean up the half, you can times the top and the bottom by 2. That will get rid of the half in the denominator. And so now my sum will be whatever 15 7/8 times 2 equals. So I take 15 7/8, times it by 2, and I get 31.75 as my sum. So the sum of the first 7 digits starting at 16 and multiplying by a half will be 31.75. Let's go ahead and just list that series. So if I start at 16, took half, I'd be at 8, half again at 4, half at 2, 1, a half, and a quarter. I believe that's 7 of them. 1, 2, 3, 4, 5, 6, 7. And then you can sort of see the actual sum up here. So I have the 16 and the 4 make 20. 8 and 2 make 10 more. There's 30. Here's the 1, and here's my 3/4, 31.75. Again, the whole idea of the formula is that you wouldn't have to list them out. This is only for 7 terms, but I need to see the formula because technically I could have said 70 terms, and you don't want to have to carry that out for 70 different terms. So I kept it small so that you can wrap your brain around it, but I want to see the formula. Okay. Second problem, we have a sub 1. We have a sub n this time. So we have the first number, we have the last number, and we know that we're multiplying by 4. So what we have is we have 4, and then if we multiply by 4, we get 16, yada, yada, yada. And we don't know how long they're doing that for, but we end with 256. So we don't know how many numbers are in this term, so we don't want to use that formula where you have to have n. If I go back, we're going to use this formula because it doesn't require the number of terms. I have the first term, a sub 1. I have the last term, a sub n, and I know my common ratio. So that's the formula we're going to use here. So the sum s sub n is equal to a sub 1 minus a sub n times r all over 1 minus r. Remember, the only thing that changes is that last part. I can't say how many terms there are, so I'm just going to leave it as s sub n because I don't know how many terms are between 4 and 256. Equals 4, take away 256 times 4. So the first 4 is my first term. Then my r value is also 4. 1 minus 4. Order of operations tells me that I need to multiply before I can subtract. So we're going to do 256 times 4 gives me 1024. 4 take away 1024. And then I can also subtract in the bottom because it's unrelated. So 1 take away 4 is negative 3. 4 take away 1024 leaves me with a negative 1020. Divided by a negative 3. And I knew that the sum would be positive because I started at 4 and I'm adding all the way up to 256. So these negatives will balance each other out. And then when I divide 1020 by 3, I end up with 340. So the sum of those digits is 340. So before you begin, you need to label what you have, figure out which formula you're going to use, be careful with your order of operations. Okay, they want us to work backwards through the sum to find the first term. Okay, so let's look at what we have, because again, we're going to use the summation formula. I just don't know which one. I don't have a sub 1, so I need to find that. I have the R value. I have the sum. So now you got to look, do I have the last term or do I know how many terms there are? I actually, very subtle clue, I know how many terms there are. S sub n, n is equal to 8. So it's very subtle, but I have n. I know how many terms I have. I don't have the last term. So I'm going to use S sub n is equal to a sub 1 minus a sub 1 times r to the nth power all over 1 minus r. Now I don't have a sub 1, so I'm going to leave that as a sub 1 throughout the problem. S sub 8 is 13,120. I know some numbers, when they're added up, equals 13,120. I don't know where I started. Don't know where I started, but I was multiplying by 3 to the 8th power, 1 minus 3. Okay, now those a sub 1s, if you don't like the a sub 1s, you could always make them x values. But what we're going to do is I'm going to do this power, and that tells me how many a sub 1s I'm subtracting here. So 13,120. Again, if you don't like the a sub 1, I can call that x, take away. Now when I do 3 to the 8th power, I have 6,561 x's there. It's just how many x's you have, all over negative 2. So you can leave it as a sub 1, you can call it x, but in the end, this 3 to the 8th power ends up being how many x's you have in that last part. There's one x up in front, and so order of operations tells us to simplify that. Let's subtract those. If I have a 1x and I'm taking away 6,561 x's, I will have a negative 6,560 x's remaining. Divided by a negative 2 equals 13,120. To solve for x, I need to get rid of that denominator. So I'd multiply both sides by a negative 2 times by a negative 2. And that leaves me with negative 6560x, or a sub 1s. And then if I take 13,120 and times it by negative 2, negative 26,240. I'm going to divide both sides by negative 6560. Okay, the negative divided by negative tells me that my a sub 1, or x value, is positive 4. My a sub 1 value was 4. So this sequence started at 4, multiplied by 3. When I got to the 8th term and add them all up, it was 13,120. Just like before, we have the summation formula, so this still means summation. Okay, and we still got to use this. It's just an abbreviation. We still got to use the summation formula. The key element here is that when n is equal to 1, this will give us our a sub 1 value. Okay, so when you plug this in, that will give you a sub n if you want to use that formula. The rate of change, if you look at this, this is your r value always, because it's what you're raising to that power n minus 1. So as long as it's written that way, that's your r value. So I need my a sub 1 for sure for either formula. I need r for either formula. To find the n value is just like before. It's top minus bottom, add 1 back. I don't know about you, but I would rather find n than find a sub n. You don't have to find both because one of the formula uses n and the other one uses a sub n. I'd rather do some subtraction and add 1 back than plug that value in and do a bunch of multiplication. So I'm going to use s sub n is equal to a sub 1 minus, I'm going to do the a sub 1 times r to the nth power all over 1 minus r. You can use either formula here. It just depends on what you find. So to find a sub 1, I'm going to plug in 1 into the formula, and I get 3 times 2 to the 0 power. 3 times 2 to the 0 power is just 1, so a sub 1 is equal to 3. I know my n value is equal to 12. Take away 1, add 1 back, so n is equal to 12. And my r value is just 2. So I have all I need. Now I just plug them in. So the sum of these 12 terms is going to be 3, take away 3 times 2 to the 12th power all over 1 minus 2. Using order of operations, the sum of these 12 terms is 3, take away 3. I got to raise 2 to the 12th power before I can multiply by it. 3 times 4,096. I'm going to multiply that by 3. And I did my subtraction down below. 1 minus 2 is negative 1. The sum of these 12 terms is 3, take away 12,288 all over negative 1. The sum of these 12 terms, and I take away 3 from that, I get a negative 12,285 all over negative 1. And when I divide by negative 1, all it does is it changes it to a positive. So the sum of these 12 terms, 12,285. And there you have it. I'm going to let you guys do the second one on your own as your last practice problem. Here's your lesson summary, freebie, and then I want you to actually do the work to find the sum in example 5. Good luck.